Given two lines, L1 and L2, determine whether the lines are parallel, perpendicular, or neither. Now, I love these types of problems because it involves some manipulations of the equations. But in addition to that, we are expected to draw some conclusions geometrically concerning the two lines. So the first thing to know is if the slope of line 1 equals the slope of line 2, this indicates that line 1 is parallel to line 2. Similarly, we can draw another conclusion. If the product of the slopes equals -1, this concludes the slopes are negative reciprocals of each other. If the slopes are negative reciprocals, then the line 1 is perpendicular to line 2. So let's begin. So take line 1 and isolate y. To do so, subtract -3x to both sides. We can readily identify the slope for line 1 is the coefficient of x. Now we apply the same procedure to line 2. 3y would be x minus 6. So to isolate y, divide each side by 3. So 1/3 x minus 2. Now, again, we have a lot of muscle memory to isolate x. That's usually our goal in algebra. But for this procedure, we isolate y, because upon doing so, we get each equation in the form y equals mx plus b, slope-intercept. Once we're in this form, we recognize that slope is the coefficient of x. So in this case, we see that the lines must be perpendicular because -3 and 1/3 are negative reciprocals of each other. Therefore, L1 is perpendicular to L2.